I have a recurring nightmare.
So do
I have this nightmare where I'm in an airport, a strange airport. I need to get to my gate. I know my flight is about to depart, but I don't know where my gate is, don't know what the flight number is, and I don't know how to get there. Then I wake up and I realize that I'm checked in, I'm packed, I'm at home, I'm ready to go. It's just a dream. I have another recurring nightmare. I have a nightmare where I've agreed to make a fancy dinner for my in-laws. I know they're about to arrive, but I don't know what I'm going to cook. I haven't planned a menu. I haven't bought any ingredients. And I know that when they arrive, I'm not going to be ready. And then, again, I wake up, I realize I've planned my menu. I love to cook. I'm a good cook. And when they get here, everything will be wonderful. It's just a dream. I have one more recurring nightmare. This is a nightmare where I have been assigned a task to provide insights to my team. I need to use data to make decisions. I need to build a business intelligence solution. I need to create a machine learning experiment. I need to provide dashboards and insights so that my team can make the right decisions and move our business forward. But in this nightmare, I don't know where the data I need is. I don't know where it lives. I don't know if it's in the right place. The data that I can find, I don't have insight into where it came from or how it got there. I don't know where it is, and I don't know if I can trust it. And then I wake up and I realize that this is the nightmare that many people face every single day, and that this nightmare is our reality. So, good morning, everyone. My name is Matthew Roach. I'm a program manager on the Cortana Intelligence information management team at Microsoft. And this nightmare scenario, so hopefully you guys are awake, you're engaged. This nightmare scenario sounds familiar in a lot of different ways. And what I would like to do today for the time that we have together is I would like to demonstrate how the information management capabilities in Cortana Intelligence Suite can help address these challenges. So let me ask just for a quick show of hands, who here is asked to provide solutions and insights for their business or their team or their customers using data? All right, so this is either everyone is raising their hand or they're saying, what a silly question, of course that's the case. So how many of you have needed to spend more time trying to find the right data to build a solution and to get it into the right shape, in the right location, at the right time, than you did actually building the insights in the final solution, the pretty pictures itself? All right, so again, majority of hands are going up. So this is, in my personal opinion, the definition of information management. So information management is the set of capabilities to ensure that you have the data that you need in the location where you need it, in the shape, in the format, in the storage location where it needs to be used or where it should be used, and that the consumers of that data, the people that need to work with it, whether it's you or others, can discover it, so they can know where it is, they can know how to get access to it, and they can understand it. They have insight into the schema of the data, its use, its provenance, so that when the time comes to build something with the data, they don't need to spend a ton of time to get to the starting point. If you think about it, finding data and preparing data is very often the tax that we pay. So at the end of the day, whoever says to you, I want you to move this data from this place to this place, if you're given a task at that level of granularity, it's because the person who is assigning the task has an end goal in mind, right? Typically, we're asked to help solve business problems. We're asked to give insights rather than to prepare data or to move data or to find data. So with the capabilities that we'll look at today, we'll see how we can enable the data scientist, the business intelligence developer, the dashboard developer, the analyst to work with the data and to make sure that it's where they need it, when they need it. Now, I've seen a bunch of people taking pictures of the slides. This is great if you choose to do it, but be aware that this slide deck is available for download on the conference website. You can load it onto your laptop, and by taking a picture of your laptop screen, you'll have much better resolution. So let's take a look at the high-level architecture diagram that we have on the slide here. So this is one of our standard Cortana Intelligence architecture slides. It's not super detailed. It's not trying to be comprehensive. But what it represents is a canonical example of the type of solution that people are building using the Cortana Intelligence tools. Typically, when you see Cortana Intelligence demonstrated, they're showing you the things that are all the way to the right. They're showing you the dashboards and visualizations and interactivity in Power BI. Or they are showing you the integration with Cortana where you can ask questions and get data and insights and visualizations back directly using more natural interaction. Or if you attended the Data Science Summit at the beginning of the week, you probably saw a lot of the machine learning aspect of Cortana Intelligence, where a lot of the actual intelligence comes from, where we have neural nets and deep learning and algorithms and capabilities to provide predictive and proactive insights and analysis on the data rather than the traditional reactive or interactive insights that business intelligence for the last 15 or 20 years has provided. What we're going to look at today is some of the perhaps less visual or less eye candy aspects of Cortana Intelligence, which are further to the left and at the bottom. And I'd like to talk sort of about the flow of the solution. We'll then provide a concrete real-world example. Then we'll jump into a demo that's based on that example. So over on the left, we have our data sources, where the top part of the diagram represents our hot path. The bottom part of the diagram represents our cold path. So we've got streaming real-time or near real-time data at the top, and more traditional batch processing, batch data towards the bottom. The bottom part is very much in line with what you were doing, it may still be doing today, but what I was doing 10, 15 years ago with data warehousing and ETL, where you have line of business systems, essentially the systems that your company, your team, your customers are running their business on today. These established systems that even though they may be 5 or 10 or more years old, they're still the bread and butter that many business workers are using every day. And I see a couple people nodding their heads emphatically at that. So this data, even though it's not, you're probably not going to see a ton of presentations about it, this is the data that the business runs on. It is the vital data to have access to for any new solutions. The hot path up at the top is something that 5 or 10 years ago, even where scenarios existed, they were not accessible. Working with streaming data, working with real-time data, doing a sliding window or tumbling window processing on top of millions of records a second. This was the complex multi-million-dollar project, not the capabilities that came as part of this solution. So let's actually walk through an example here where at the top we have streaming or diagnostic data coming in. This could be an Internet of Things solution where, like right now, every time I do a presentation, I put my band in exercise mode so I can track my heart rate and see just how stressful it was being on stage. But this band is generating multiple events per second, and when it syncs with my phone, or as it syncs with my phone, sending this information up to a service in the cloud. This could be a smart building, it could be a fleet of cars, it could be a manufacturing system, but in this example, we've got devices and equipment that are generating data about their health and about their activities, and they're submitting that using a service called Event Hubs. So Azure Event Hubs is a fundamental service that builds on top of Azure Service Bus, and it allows for the high performance transmission and accepting of millions of records per second or millions of events per second from any number of connected devices. Now, Event Hubs is going to be only mentioned in passing today, because for the most part it is a programmatic tool. So the client application that's running on the device, that's running in the sensors, or that's reading from the sensors, it's using an API and it's submitting things using code, be it C# or some other language. But the configuration of Event Hubs essentially ensures that as the data is submitted, it's available and it can be consumed by whatever subscribers, whatever event subscribers are interested in and listening to that data. In our example here, we actually have 2 different subscribers, and each of them are Azure Stream Analytics listeners. So the bottom one, the one that is towards the left of the slide, this is our archival job, or our persistence job. So as the information is streaming in, even though we have scenarios where we'll want to get real-time insights and actually track things as they're happening, or do things like anomaly detection. You know, maybe it's network traffic that's coming in, right? You want to be aware right away if there are problems with your network or the process that you're monitoring. But you also want to have a persisted store moving forward. Who here has implemented or is in the process of implementing a data lake? So we're maybe 20%, maybe a little bit less. So it used to be, back in the data warehousing days, back when the data warehouse was your biggest store, that your data warehouse schema was predefined, and the information that went into it was put into this predefined schema to help you answer the questions that you already knew to answer. Now, this is great, but IT and the data platform, the data team, is being asked to be more responsive and more agile. We're being asked to answer questions, or be prepared to answer questions that no one has thought to ask yet. The data lake essentially comes in where having the information, all of the information stored in its raw or close to raw form, so that when we think of new questions to ask, we'll have that available to go out and define the schema towards the end rather than towards the beginning. This Stream Analytics job essentially listens to all of the events coming in through Azure Event Hubs and persists them to Azure Blob Store, to HD Insight, to Azure Data Lake. There are multiple technologies where this can end up, but essentially this is a way of ensuring that either at the granular level or at the aggregate level, all of the information that's coming in is reliably persisted for future analysis and then becomes part of the cold path. Towards the top, we have another Stream Analytics job where the information that's flowing into the system is being passed on in real time, again, either aggregated or in raw form, to a Power BI dashboard. So Azure Stream Analytics integrates in with Power BI, where just as you can define an output for your Stream Analytics job to save the information somewhere, you can also specify a Power BI data set as the destination. So Power BI has the concept of a streaming data set where as the information is flowing in, it is updated and can be displayed in real time or near real time. But let's move away from the hot path and look at the cold path down below. Once the information has come in, both coming in from the devices through Stream Analytics and Event Hubs, or coming in through line of business apps, enterprise data warehouse, whatever your structured or unstructured data sources are, towards the bottom left, we also need to ensure that we can have that data also in the right place and at the right time. To help with this, Azure Data Factory provides capabilities for the orchestration, movement, and execution of data at scale in the cloud using either on-prem or cloud, structured or unstructured data sources. So both what is frequently seen and which we'll see in the demo today, Azure Data Factory will allow you to connect to existing data sources, again, on-prem or in the cloud, and to transform them or modify them through activities and pipelines. You can essentially say, using this input data set and this output data set, I want to execute this Hive script, this .NET job. I want to perform this activity to transform the data and output it where it needs to be. Here, it could be transforming and persisting in a different format or a different location in the data lake. But what we're doing for a lot of scenarios, and again for the demo scenario today, we're outputting this information both into a SQL Azure database or a SQL Azure DW store for high-speed analysis. So again, getting back to data warehousing, it's the questions that we know to ask today. So we'll transform it into that state so we can get quick access to that. And we can also integrate in, as part of our Azure Data Factory pipelines, we can execute Azure Machine Learning Web Services so that as the data is flowing through, we can submit it to these trained machine learning algorithms and models to get insight on the data and then persist those insights, again, to make better, more proactive and predictive decisions. Now, the biggest question here, of course, is where is the data? At each point along the way, these services are producing and consuming data. How do the people who are building the Azure Data Factory pipelines or building the data warehouse or building dashboards on top of the data warehouse, how do they know where to find the data, what the right data to use is, who to go to ask questions about the data? This is the problem that Azure Data Catalog is designed to solve. Azure Data Catalog is a service for data source discovery and understanding, where data sources are first registered into the catalog. So the catalog serves as a metadata repository. It knows the location of the data. It can have information about the schema of the data, including previews and data profiles. And it's built on top of Azure Search, so it provides searching, browsing, filtering in a user-friendly interface, not just for techie people, but for anyone who would want to consume and work with data. So Data Catalog enables data producers to register the data assets that they're creating so that other teams and other users can get more value from them. And that allows data consumers to have a single place to look to find data assets across the organization. Have you guys seen Rolls-Royce mentioned in other presentations this week? Yeah, a couple hands go up. This is one of our flagship customers, or at least one of the flagship examples that we use for Cortana Intelligence. The first time that I saw that Rolls-Royce was one of our customers, I was very excited because I love cars. And then I was informed that Rolls-Royce today is not the car company that I've always thought of them as. They are primarily producing aircraft engines for the travel industry or for airlines. And Rolls-Royce's business model is very, I want to say cloud forward, or it's like the physical manifestation of cloud computing or time sharing, where Rolls-Royce, for the most part, does not sell engines to airlines. What Rolls-Royce does is it leases the engines and sells their time, and the only way that Rolls-Royce makes money through this model is through the operation of their engines. So flight time, run time, actually using the engines. So the converse of this is that any minute or any hour or any day that a given engine is not in operation, Rolls-Royce is not making money, they are losing money. And what Rolls-Royce has identified is that unexpected downtime or maintenance in general is one of their biggest business risks or business costs. So if you guys, so I assume most of you flew to get here. Did anyone have a maintenance delay on the way in? So one, all right, only like 3 people in the whole room, 4 people. So we have a very lucky crowd today. I used to travel a lot, and maintenance delays seem to be very frequent in my life. But what Rolls-Royce is doing with Cortana Intelligence, at least the primary aspect, the aspect that we'll be looking at in the demo, is a predictive maintenance scenario. What Rolls-Royce wants to do is it wants to know not, does this engine have a problem? So I have to take it offline and fix it. It wants to know, when will this engine have a problem, so that as part of our ongoing scheduled maintenance, instead of waiting until something actually goes wrong, we can predict what will go wrong and when it will go wrong, and then proactively fix it in the window that we've already contracted for maintenance, thus optimizing the revenue stream for each engine. And to do this, there are 2 primary data streams that Rolls-Royce is sending to Cortana Intelligence. So they've built a solution on top of the Cortana Intelligence suite, very similar to what we looked at in that high-level diagram. And the first thing that they do is they actually have a wireless network. So while planes are in flight, their highest value data is being sent in real time to the cloud. So there's information being sent from these instrumented engines, thousands of events per second, and that information is being used in real-time models to ensure that there's nothing significant going wrong. Then, when an airplane lands and arrives at the terminal at an airport, there's a dedicated wireless network that the systems on the plane will connect to, and they will then submit the bulk of the data. There's a huge amount of data that's gathered for every flight hour, and this information is then offloaded from the plane and into the cloud for additional analysis. But through this model, Rolls-Royce is able to ensure that for all of the engines that they have produced and delivered to the airlines, that they're getting the maximum return on investment. And of course, the side effect is the airlines love this, because anytime that they have an unexpected delay, there are costs and implications for them as well. And as a flyer, I assume that there's benefit for us too. Now, the other thing that Rolls-Royce is doing, which isn't really highlighted in our demo today, but which I think is an awesome thing for airlines to be doing, is what the greatest expense for an airline is. What is their single biggest expense by almost an order of magnitude? Fuel. Even with fuel as cheap as it is today, it is still dramatically the single biggest expense for any airline. So some of the information that Rolls-Royce is gathering is related to the fuel efficiency and the operational parameters of the plane. What they've found through their analysis with Cortana Intelligence is that the biggest indicator for fuel efficiency, actually, let me step back a little. There's an axis of behaviors where on one end of the axis, you're optimizing for fuel efficiency. On the other end of the axis, you're optimizing for passenger comfort. The two are pretty strongly opposed. So the most fuel-efficient way to make a landing is a sudden, rapid, near-vertical descent. So probably not what we want to see, right? So with this framework established, or with this baseline established, what Rolls-Royce and the airlines have found out is that the biggest predictor for fuel efficiency within the acceptable parameters of passenger airfare is the experience and tenure of the airline pilot. So experienced pilots know how to optimize the two. They get used to the feel of the plane. Rolls-Royce is working on feedback mechanisms to send back information about those parameters or those behaviors, so that less experienced pilots can be more fuel efficient, save the airlines money, and again, make the airlines more likely to work with Rolls-Royce as opposed to a competing engine manufacturer. So this is a lot of talking. Let's actually look and see what the demo is and what the components are and how they work together. So our environment is a specific example of this canonical example. So if I build this guy out, you'll notice that for the demo, we do not have any true cold path data coming in. Even though there are a few reference data sets that have been preloaded into Azure Blob Store, the primary input that we're working with is this diagnostic information that's coming in through Azure Event Hubs and Stream Analytics. We've got some Power BI dashboards. We've got some machine learning models. We have data being stored in Azure Blob, transformed and orchestrated using Azure Data Factory. We're using Azure Data Catalog for the discovery and understanding of the data as we move through the path. So at this point, before I jump into the demo and switch machines, I want to pause and ask if we have any questions so far, and to encourage questions as we move through the demo. I will be heads down, so I just wanted to make sure that we have, that there's no questions. So fire away, sir. So the question is essentially, what's the format of data that's flowing in through Azure Event Hubs? The two primary formats that are used are either JSON or CSV. Typically, there is an application with a predefined schema that is submitting these events through the Event Hubs API into the cloud. Each Event Hub has a specific schema that it is designed to accept. So whether or not there was an ETL or similar process upstream depends on whether or not the original data format and the desired data format here match. The typical pattern that we see is that the information that is coming in furthest to the left is as close to raw as possible. You don't want to have destructive transformations upstream before you persist the data, because that will prevent it will restrict the usability or useful scenarios over time. Did that answer your question? Okay. Yes, sir.
In your architecture, you showed there is the stream from Stream Analytics to Azure Blob to Azure Data Lake. Is there any reason why there is blob in between? Or?
Okay, so the question, I'm actually going to back up one slide here. So is my pointer, my clicker is not my friend today. So is there a reason why we've got the line between Azure Blob and Azure Data Lake? This is more than anything a PowerPoint artifact, or perhaps the slide doesn't show. It's not designed to be a flow. It's designed to show that both of these services provide related or potentially overlapping capabilities. Each one of them has different strengths and weaknesses, both from technical or billing perspectives, but we are not suggesting that we would go from Azure Blob Store into Data Lake. So thank you very much for calling that out. All right, I'm going to switch machines. I want to mention one more nightmare that I have that came true. I have not recurring, but I have a nightmare last night that I was doing a presentation at Microsoft Ignite, and I had my primary hand broken badly at the thumb, which reduces my ability to type and mouse. So as I move through the demo, let me throw out the disclaimer and the apology in advance that I am walking wounded to some degree. So I've tried to tailor the demo experience to limit the amount of typing and the amount of mousing that I will do. We'll see how it goes, but I'll be keeping an eye on the clock to make sure that I'm not slowing things down too much as we go. So what I've got on the screen here is my Azure portal. So this is the standard Azure management portal, and it demonstrates the different services and components that are involved in the demo solution. So if we start thinking again about the diagram, if we start from the left on the top, the first thing that we have, which we're not going to really go into a ton of depth on, but I've got this Azure app service, which is running a continuous HTTP app. So basically, it's a web app that is just running forever. This is my quote-unquote engine for this example, for this demo. So I have code that is simulating engine output. We're actually using as one of our sources a data set from NASA around the reliability of turbofan jet engines. So it is as real data as we can get without tying into an actual jet engine that's out there. And this information, or sorry, this app is what is calling the Event Hubs API. The Event Hubs themselves are set up to listen to this information. So the Event Hub is essentially has listeners and it has subscribers. So the information is coming in, and we have, let me come in here. So we've got a single Event Hub, so our Ignite demo EH. And we've got different consumers. The significant ones, the things that I want to call out here, is we've got a consumer for Power BI. We've got our PBI CG for consumer group. And we've got our Ignite demo blob consumer group. So Event Hubs allows you to define policies for retention and performance. So having consumer groups defined essentially allows you to say, this is the type of performance, this is the type of retention that we expect for the different listeners that we have consuming the data that's flowing through Event Hubs. In this case, both of them are Stream Analytics, but Event Hubs has additional consumers that you can configure and use as well. The great thing about Event Hubs is its reliability, so the guaranteed exactly once delivery. So using Event Hubs, a lot of the things that when worrying about data transfer and transactional integrity that you would need to take care of yourself if you were building a streaming solution from scratch, the platform takes care of it. And there are levers that will allow you to configure performance and scale with different hubs, different partitions, and different subscriber groups. As a general rule, as is the case with many cloud services, the higher performance that you're configuring for, the greater your monthly bill is, but it's very easily configurable. Now, the thing that we're actually going to look at in greater depth here, we're going to go in and look and see how this is set up, is our Stream Analytics jobs. So as the diagram showed, we have two Stream Analytics jobs. The first one, and the simplest one, is taking information and persisting it to Azure Blob Store. So this is what we've selected here. The first thing that I want to call out is this basic format for Stream Analytics. For each Stream Analytics resource that you create, you define a set of inputs, a set of outputs, and a set of queries to map them. A lot of the other cloud stream processing services that are available, I apologize I'm having a competition name failure right now, but there's part of the Apache stack, and I feel awful for not remembering the name, provides complementary or competitive services for stream processing in the cloud. Storm, thank you very much. I wanted to say Spark, and I knew that wasn't it, so Storm. Storm has a Java-based API where, for the most part, you need to actually write real procedural code to implement your stream processing. One of the goals for Stream Analytics was to ensure that that this was as straightforward and easy to set up, configure, deploy, and run for people who weren't dedicated streaming developers. So in this model, each input is referencing either an Azure Event Hub source or an Azure IoT Hub source. So Event Hubs and IoT Hubs, again, complementary service. They're both about getting messages and information from connected devices into the cloud. They have different performance characteristics and different, I guess, platform details, so different authentication, different APIs. The reason we're using event hubs here is because we are looking at one-way communication. So event hubs is all about ingress into the cloud, whereas IoT hubs is designed to provide communication bidirectionally between connected devices and cloud services. So event hubs here, so the event hubs here let me click on this guy. We're essentially able to say that we've got streaming data coming in. And notice that this job is running right now, so the information that we're looking at here is read-only. But the configuration for the input is basically just a matter of saying, where are we getting the data from? The two primary types of input are either streaming input, so IoT hubs or event hubs, or reference data, where that reference data could be either blob store, table store, SQL Azure, some cloud-based, Azure-specific cloud-based persisted store, so that if you wanted to join your streaming data with reference data, so you've got IDs that you can join the two of them together on, it's simply a matter of creating multiple inputs, one for each stream, one for each reference data set. And perhaps the most common question that I see here is, can I access resources in other Azure subscriptions? Because very often companies will set up different subscriptions for different business units or different groups. And very often the types of solutions that you're building for Cortana Intelligence is using data from multiple subscriptions. The answer is yes, and it's simply a matter of configuring it off to the right. The two options that you have are either to pick from resources in the current subscription or to manually enter them as we've done here. Now, the outputs are configured very similarly. So, come on. Again, apologies for the mousing here. Let me close this guy out because that is not what I wanted to look at yet. We'll click on our output. So for this simplest example, we've got a single output which is defined in Azure Blob Store, where we have pointed it to, as it loads, we've pointed it to a specific storage account. We've defined both a format for the files, and we've defined the naming and partitioning convention. So how often are we creating files? How are we naming them? How are we labeling them? So we've got this, the path pattern that is using the day and the hour. We've got the date format specified, so you can picture all of the files that are being created here. But the thing that makes Stream Analytics for goodness sake, Matthew. There we go. So the thing that makes Stream Analytics as useful and efficient from a development perspective as it is the way that it processes queries. So Stream Analytics has a SQL variant or a SQL dialect for defining inputs, outputs, and the relationship between them. So here we see we're doing a select star. We could also list explicit column names from what? This is not a table. This is our event stream. This is the input event hub source, or I guess that's the from. It's the blob store that we defined as our output from the event source. The only thing that's necessary to hook these up is having the query that says, get information from this source and put it into this destination, or from this input into this output. And when the job runs, any information that is flowing through that event hub is going to be transformed using the rules of the query and put into those destinations that are specified. So we also have the ability to do monitoring and management to see the execution and the performance and track errors and so on. But what I actually want to do is to look at our Power BI Stream Analytics job. So remember, we had the two different paths. We had the persisted path, where we're essentially just taking all of the raw data and writing it in its raw, non-aggregated format down into our blob store. Here we have a more interesting or complete scenario with our Power BI outputs. So instead of saying blob store for our sync type or for our output type, we're basically saying that for each one of these outputs, it is a named Power BI data set, and these are configured pointing, these are configured pointing each one of these outputs at a specific Power BI account. So you specify the credentials for the account that's used to connect to Power BI. Looks like our network is having a little bit of trouble here. Usually doesn't take quite so long to load. And this essentially establishes the context in which that data set is going to be created. Once this is done, any Power BI user in that account that has access on that data set can build dashboards or other visualizations on top of this streaming data. So this is essentially a way to say, as the data is flowing in through Event Hubs, it's going to be available for real-time dashboards through Power BI, again, without any code beyond a SQL query or two, or in this case, 3, because we have 3 outputs. Now, one of the things that we saw earlier is that the query was nice and pretty formatted for the simple one. One of the things that I found, which it's my bad that I haven't reported this as a bug to the Stream Analytics team. If we have multiple queries in the same job, the formatting, the line breaks, and so on are lost when the query is running. They're still there if you're not in run mode. But what I've done is I've proactively copied these queries and formatted them for easier reading in SQL Server Management Studio. I do want to stress that this can't be actually executed in SQL Management Studio. I'm doing it here simply for formatting and readability. But where we have multiple inputs and multiple outputs, we'll have one query per output delimited by semicolons, just as if you were putting together a SQL batch. The first one is a specific set of processing. So we're going to do a little bit of data manipulation, and we're getting just a subset of columns. But this information would be used for the full data stream. Every event that's flowing through will be sent into that streaming data set in Power BI. Because there's no aggregation, the other two are a little bit more interesting. And the thing that I want to stress here is this clause, or this function in our group by clause. So here, for both of the lower two queries, we're doing aggregation to provide summary, time-based insight on the data as it's flowing through. So we're doing aggregations, and for the first one, we're saying, I want to have an output record produced for this streaming data set once every 5 seconds. Now, there are different temporal semantics that you might be interested in. A tumbling window and sliding window are the two that I see most often. A sliding window is essentially, so if we had sliding window, second, 5, we would actually be producing an output every second where the data in that output was aggregated for the previous 5 seconds. So you've got more outputs with different relationships between them. What's being produced here with tumbling window is what I see most frequently when we're doing Power BI integration, when you're actually visualizing the data rather than persisting it or programmatically working with it, where it's simply every 5 seconds there's an output and there's no overlap between them. There are multiple additional functions that we can use here, but again, these are two of the most common ones. And what we're doing for these two streaming outputs is we're aggregating once at the granular level to say, for an engine in flight, here is the information for every 5 seconds of flight time. And down below, we're getting information at a higher level at simply once per hour. Now, that is not where I want to be. Let me come back in here, and I'm going to close this out, and we are going to look at Azure Data Factory as well. So Stream Analytics for hot path processing, working with this real-time data as it's flowing through, SQL-based language designed to get information from your input sources, persist them, aggregate them, make them available for visualization. Data Factory is designed for batch processing. It's more analogous to a traditional ETL or ELT type tool with capabilities for connecting to data, for moving or copying data, and for executing processes that transform the data. One interesting thing about Data Factory that differentiates it from, for example, SQL Server Integration Services, which is a ETL tool with which we may be more familiar. Integration Services has its own data flow pipeline where it will manipulate the data as part of its core process. So SSIS is all about the high-speed transformation of data as it flows through the data flow. Data Factory does not have its own data transformation or execution engine. What it does is it has activities that can integrate in with other sources. So a very common pattern that you will see is there will be an input data set and then a copy activity. So we're going to go from a SQL Server database on-prem and load that information into an HD Insight cluster in the cloud. Then we will execute a Hive activity that has an HQL script that will actually perform the transformation, which moves or copies or aggregates the data. Then there will be another activity, such as Azure Machine Learning, that will do additional processing on it. But the primary pattern for Data Factory is around orchestration, management, and delivering similar scenarios, but with a different pattern. So one of the core concepts in Azure Data Factory is that of a linked service. So a linked service is essentially a data source location that Azure Data Factory, or this specific Azure Data Factory job, is aware of. What we have for our demo today are 3 different data stores. So we have both the blob store that we're getting our information from. We have the HD Insight Hadoop service that's running on top of the blob store. And we have a SQL Azure Link service where we are outputting the information of the processing when it's done. We also have 2 different compute linked services where these compute resources are where we actually do our executions. The HD Insight cluster on the bottom is, again, one of the resources that's part of the solution, and it is being used for the transformation of data, whereas the Azure Machine Learning resource is being used for predicting the maintenance window or the reliable useful life or predicted useful life of the engines based on the data that's flowing through. Now, each one of these is a set of connection information and configuration. The other thing which is not present in this particular factory, this particular solution, is we have the ability to have linked services that are based on data gateways. The reason that we don't have any gateways in this factory is because all of the data and all of the resources that we're working with are already in the cloud, so we don't need an additional set of capabilities to access them. If you are working with on-prem data, be it SQL Server, Hadoop cluster, whatever it is that you have on-prem, if you're working with that and you want to do processing on it through Data Factory, you'll need to configure an enterprise data management gateway, which is basically a software service using Azure Service Bus that will allow the cloud computing to securely access the on-prem resources. So this way, once the gateway is configured, you can have a reach back to the data that's on-prem to pull that data in or to push data from the cloud to your on-prem resources. So let me close that. So what I want to do here as we look in a little bit deeper is I want to come into the diagram view. So this is an end-to-end flow of what this data factory is processing, so the data sources or data sets that it's working with. You'll notice that there is sort of front and center, the big red bar and the red icon on this top data set. Let's actually look at this guy a little bit deeper. Let me resize this so we can still see it. So this is the location where we are drawing our cold path or reference. Sorry, this is where we're getting the data that's been written from our stream analytics job. And as you can see, today's processing is running just fine. But one of the things that Data Factory gives us is history, including error information and details about the errors as the process or as the activity has been running. So here, when we first configured or when I first set up this demo solution, not all of the pieces were in place the first time that I went through to test it. So having this historical information makes it very easy for someone who is working with Data Factory or trying to diagnose problems or get insight into the execution. Very easy to go in and see what's going on, what's been succeeded, what's failed, et cetera. Moving further down, so we've got a data set, we've got a pipeline with a single activity. I actually want to look at this pipeline with multiple activities, and again, apologies for the bad mousing here. This is the ongoing challenge. The core of the processing in this, particular Data Factory comes down to having the data transformed into the format that our machine learning job expects it to be in or needs it to be in, and then actually submits it to the machine learning job for processing. Even though I haven't mentioned this or reinforced this in a while, the goal, the business goal that we're trying to achieve here is to have this machine learning job predict when a given engine will fail based on the data as it's flowing in. This is the core of enabling that solution or enabling machine learning to do its work. And inside the pipeline, let me scroll down one more time. I want to essentially show where we put the code in, if that makes sense. So we've got a single input data set, a single output data set, and because we are using HD Insight and Hadoop and Hive for the storage, we're also using Hive for our processing. So we've got an HQL script or Hive query language script that is taking our inputs, transforming them based on our business rules, and putting that information into the outputs. So again, referencing back to integration services, we don't have a data flow with boxes and arrows for the transformations. What we do have is the ability to take our existing query skills, take a script, put it into the pipeline where it will be executed as part of the overall orchestration. And some of these can be complex, but this is also an opportunity where having multiple members of the team collaborating. You may have the Hive guy on your team or the Hadoop guy on your team who is giving you the script to run if you're not the Hadoop expert. And hooking it up to machine learning is, there we go, very simple as well. So let me just focus on the fact that the type of activity, we've got a batch scoring activity. Azure Machine Learning has two primary web service deployment models. So when you build a model in machine learning, you deploy it as web services that are either transactional, where they take a single event or a single record to do predictions or other results on, or they can accept batches of records for different processing models. Here we have essentially configuring it to go against that predefined link service. So we point the link service at the ML model. Here we say this activity is going to execute it using this input data set, again, one of our linked services, and this output data set, where this output data set is going to be putting the information into SQL Azure for consumption, both by downstream processing and Power BI reports. So let's close this guy for a quick second. One other thing that I want to point out about Data Factory, even though most of its capabilities are here in the Azure portal, the Data Factory team is working on some new scenarios and new tools. And in addition to a focused and efficient copy data tool, so even though Data Factory is very powerful, one of the things that we've heard from customers is that doing something that's super, super simple, like copying data from point A to point B, you have to do a lot of the heavy lifting yourself if you go through the regular designers. So we've built a wizard-like copy data tool where you specify your sources, your destinations, and the schedule you want it to run on, and boom, it just runs. The thing that I want to point out, which is also outside of our Azure portal, is our management and monitoring tool. So this is in the same shell as our copy data is in. So it's I'm not going to name the shell because we have an internal name that we always use. And again, I'm having a vocabulary failure for the name. But here we can get insight into the activity over time. If you look on the right-hand side, we can get insight into what's been successful, what has failed for any of the activities that are anywhere inside our data factory. So in addition to that graphical view, the design view for the factory and the pipelines and the activities as a whole, we also have a runtime view to examine it both as it is running currently and its historical activities over time. And this is perhaps one of the most frequently requested capabilities for any data movement or orchestration tool. It's great when it runs, but when something bad happens, how do I find out? This is a way to provide capabilities to easily answer those questions for the exception cases. So what we haven't looked at so far is where the data comes from, how do we find it, how do we know what the right data is to work with? And this is where Azure Data Catalog comes in. You'll notice the Azure Data Catalog is in a different tool. It's not built into the Azure portal. And the reason for this is that Azure Data Catalog is designed to be used by as many people as work with data. It's not an IT tool. It's not a developer tool. It's a tool for data consumers and data producers. And this may include people where if you were to say, this is in SQL and this is in Oracle, they would not quite figure, they would not quite understand what it is that you're referencing. So at AzureDataCatalog.com, we have a web portal which provides discovery and registration capabilities. And I've got our data source registration tool opened up already. So the Data Catalog Data Source Registration Tool is a Windows Click Once application. So essentially you launch it from the browser and it will allow you to select whatever data source you want to register. If we think about the basic pattern, how do you, so I'm going to pick on the gentleman in the front row because he's been very interactive so far. How do you know what data sources or where the data is for a given problem that you're trying to solve? Okay, I don't. So how do you find out? So this is a very common pattern. So if you don't know where the data is, how do you find out? Because you need that to you ask people. So this is what I see across Microsoft and pretty much every organization that I work with. So if I don't know, I probably have an idea of who might know. So I ask Bob, and Bob says, go ask Susie, and I ask Susie, and he says, ask Sven. So I go sort of this manual detective work, like data archaeology. I knock on doors, I make phone calls, I send emails, and eventually I will find the answer. And it's the same thing again and again and again. And from that point on, here's sort of like the worst case scenario. How do other people know how to find the data? They come and they bother you, right? Because eventually they figure out that you're the person who knows where the data is. So registering a data source into Azure Data Catalog is a way to keep from becoming the person that gets bugged about data all the time, or at least ideally that can be the case. So registering a data source is a way to get the metadata and information about the data source into the catalog. So as a one-time step, I needed to provide the connection information. So I'm the data expert, I'm the data producer, I'm the person who knows where the data is. So I have the server name, I have the account name, whatever it is for the specific data source type that I'm registering. Once I do this and put that in, my app, so this is running locally on my machine, there's no cloud configuration required. So the data source registration application is now connecting to, in this case, Azure Blob Store. I can see the hierarchy of containers on the left. If we had connected to SQL Server, reporting services, or Oracle, we'd see different things in our hierarchy. But I can maybe choose the experiment output container. And inside of it, I can see the directories that are being produced by the output of the machine learning model in Data Factory. And I could say, I'm going to select all of them. I am going to provide a where are we going? See, this is my typing saving. So I'm going to provide, in addition to the set of assets that I'm registering, I'm going to provide an expert or set of experts who can be identified as the point of contact for questions about the data. So if I find it and there's not enough metadata in the catalog, this way I don't need to make all of those phone calls. And I can provide a set of tags as well. And when I click on register, the data source registration tool is going to connect to those data sources, extract available metadata, and then use the data catalog REST API to submit the information to the catalog in the cloud. Now, some of you are looking at this and saying, boy, those names aren't really super useful. So they're all GUIDs, right? So why are we registering those? That is an excellent question. Let me actually jump from here while the publishing is going on. And we'll look at some of the capabilities that are in Data Catalog. So the thing that I want to stress is that the home page has sort of like a customized or personalized dashboard to give you information about parts of the catalog that are relevant to you. On the left, I can see things that I have recently interacted with. In the middle, I can see assets that I have explicitly pinned, such as pinning a document in Word or a presentation in SharePoint in your file menu. Over on the right, I can see saved searches, which are predefined subsets of the catalog that either I've created myself or a catalog administrator has assigned for other users. And what I've got as the second one on the list here is this predictive maintenance experiment output. And I'm going to click on this guy. The saved search itself is essentially the like a view on top of the catalog contents. On the left-hand side, you can see the tags or other filters that have been defined. In this case, what we've done, or what I've done when I set this up, is I have set it to constrain the scope of the catalog just to this experiment output Azure container, Azure storage container. And when I select this, in addition to seeing all of the individual directories that are inside, so the things that I have actually registered, I can also see over on the right-hand side business-specific or consumption-specific metadata about where the information came from. You'll notice that in addition to the technical name, so that programmatic name, because there's restrictions on spacing and casing and so on. So we've got experiment output for the underlying name. We've got a space in it for the friendly name. But this information is all added to our index so that you can search, you can discover, you can review what's there. And one of the defining characteristics of Azure Data Catalog is that any user can contribute their own perspective. So if you find something and it's tagged in a way that some other team thinks about it instead of the way that you and your team think about it, you can add additional tags. Every user can add their own description as well. So when you discover something, you can see not just the perspective of the IT guy, but the perspective of everyone who has contributed. And of course, if you provide input and another user provides input, you can't delete somebody else's or edit somebody else's stuff. Everyone has their own perspective, and everyone can see who added what information as well. Now, the metadata that's available is, that is not what I want to look at. I actually wanted to go back here. So the metadata that we extract from the data source is more or less complete depending on the data source itself. For Azure Blob Store, we're not getting a lot of metadata because it's unstructured. We can't get column names or similar things easily. What we can do is as part of the job that is populating the Blob Store, so a very common pattern that we see is as part of Azure Data Factory, you'll have a .NET activity or similar activity that will call the Azure Data Catalog API and actually register each thing as it's coming in, as it's flowing through the pipeline to keep it in date that way. But I actually want to jump in here and take a look super quickly at some SQL assets before we start wrapping things up. So I've gone to another save search to look at that predictive maintenance database that it's near the output or near the end of our scenario. So here we can see, come on. Of course, I had clicked on the other guy there. So I can see database level metadata, perhaps the single most useful or functional set of information that we can have in the catalog is request access information, so that when someone finds something, you remember we're just storing metadata, right? So registering an asset into the catalog doesn't give anyone permission to connect to the data source itself. It's simply allowing them to discover and understand it. So when you find an asset in the catalog, you can then understand what is the process that I go through to get access to it, what security group do I need to join, where is the process documented on SharePoint, who do I need to email to get the username and password, something along those lines. And when we register, so unlike the Azure blobs, when we register a structured source, be this SQL, Oracle, Teradata, MySQL, Hive, whatever it is, if it has the concept of a table, if it has the concept of columns, we can extract both a snapshot of the preview. So this is an option that the user has when they're registering. We basically do a select top 20 or something, whatever the parallel is. We can also pull in metadata at the column level, and we can also allow users, or the catalog also allows users to annotate at the column level as well. So you can tag and provide descriptions, both to make them more easily understandable and to make them more easily discoverable because they are included in our index. For structured data, we also have data profiles, and we have the ability, let me actually jump down here and look at the stored procedure. We have the ability to provide rich text documentation as well. So if there's something that doesn't fit naturally into a tag or a description, you're able to elaborate on that to provide richer context so that when a user discovers the data asset that's been registered, they can understand how to use it, where it came from, things along those lines. So as we wrap things up and then open up for general questions, I want to do a quick summary of the services, but this gentleman is politely raising his hand, so he's going to get to ask his question first.
I just wondered if you can leverage this catalog in some of the other tools?
So the question is, can we leverage this catalog in some other tools? We have integration today that will allow you to open the data that you discover in other tools from within the portal. So when you find a table, you can say open in Power BI Desktop, Power Query, Excel, or SQL Server data tools. And we have a small but growing set of tools. One of the things that we're actively looking at is integrating directly into other tools so that you can search and browse and filter without needing to go to a dedicated web page to do it. That is not yet in place today. So Stream Analytics provides the ability to do processing on millions of records per second, allowing or using SQL-like queries with multiple inputs, multiple outputs, whether they're streaming data through IoT Hub or Event Hub, or reference data in Blob Store or SQL, or going directly to Power BI outputs as well. Azure Data Factory gives us the ability to do data composition and orchestration with both a graphical surface, they like to call it the single pane of glass for managing and monitoring, gives you the ability to work with structured, unstructured, on-prem or cloud-based data through the gateways for the on-prem, and providing multiple capabilities for both tracking relationships and lineage inside your data factories and pipelines, and monitoring the health and execution of the factories as they run. And then Azure Data Catalog provides services for data source discovery with a crowdsourced metadata model to allow multiple users to provide their perspectives. And in addition to the capabilities that Data Catalog delivers, all of the capabilities in the portal and the registration tool are built on the same API that is available to customers. So integrating in with your ETL job or your data lake population process or a custom reporting tool that you rely on, all of these are possible using Data Catalog as well. We actually have multiple partners who have built their own custom experiences with Data Catalog underneath. One thing that I want to stress is that evaluations are super important. I feel, and I waited until the end to say this because it's going to weird things in the room, I feel bad about the demo being less buildy and more looky than it was, so I will apologize for that, call that out in the evaluations as necessary, but definitely fill out the evaluations. We look at these to understand what people are looking for next year or other conferences or other events. But because Ignite is not over yet, there are additional resources that are available here at the show and after the show. The sessions down towards the bottom are related to one degree or another with what we've talked about today. So later this afternoon, there is a session on leveraging Cortana Intelligence Suite for modern data warehousing scenarios. So this is another look at some of the same capabilities, but with a focus on data warehousing rather than a predictive maintenance or similar solution. Friday at 12:30, you sort of have a pick or choose. The one that I would choose if I were still here at 12:30 tomorrow is the first one, that 3106. One of the data scientists from our machine learning team is going to look at the other side of this same solution. So she's going to look at the ins and outs of building a predictive model or predictive maintenance model. So if you're interested in seeing, because we looked all around it, but we didn't actually look at it. If you're interested in seeing what goes on in the model itself, that is the session to attend. If you're interested in more technical details and scenarios around event hubs and streaming at scale, the other one tomorrow may be a better choice. And there's also a hands-on lab over in the B Hall that's dedicated to building predictive models as well. So you can actually walk through hands-on end-to-end. The other thing that I want to stress is that the solution that we were looking at today is based on a solution gallery or a Cortana Intelligence Gallery solution that is available to you. So if you want to actually get your hands on and explore this particular solution in depth, if you go to that first link, you can actually, by logging in and identifying a subscription, you can actually deploy all of these services to your own Azure subscription to spend as much time with them as you want to. And this is one solution of many. So there's a variety of scenarios that showcase the capabilities in Cortana Intelligence. So with that, we are near the end of our time. I'm going to open up the mic for questions if you have any. I also want to point out that for most of the morning and perhaps into the afternoon, I will also be down at the Cortana Intelligence booth in the expo hall. So if you don't want to ask questions now, but you do want to have questions or discussions later, you can look for me and other members of the team there. So thank you very much.